Okay, we're going to work through the answers to the Unit 12 practice test. Now, the very beginning of the practice test just has this big chart, and this chart is going to be extremely useful. You're going to use that on a lot of questions. And what does it tell us? It tells us over here, which ones are the most likely to get reduced, and they're all written as reductions. And the voltage there tells us, the higher the voltage, the more likely it is to be reduced. Okay, and it goes from here, and then it continues over here. So this is a really useful chart. We're going to need this. Okay, then down here, just a little section that just to kind of help you get your ideas together. Okay, oxidation. Okay, so we said Leo the lion says grr. So Leo and grr. So oxidation is losing electrons. Okay, what does that look like? If it's losing electrons, that means the electrons are on the right side of the equation, and the element is going to get more positive, and oxidation always occurs at the anode. So just get those four things all together. In the same way, for reduction, okay, reduction is when it gains electrons. That means the electrons are on the left-hand side. Okay, that always happens at the cathode, and the charge on the thing gets lower. The charge is reduced. It gets more negative. So those things are true on both of these. Okay, let's go on to the questions. So first off, it says, determine whether we're talking about oxidation or reduction or neither. So an element is gaining electrons. Gaining electrons is reduction. Grr. Cl in this reaction. Okay, in a compound, Cl is -1. Okay, and in this compound, it's also -1. So it is neither oxidation or reduction for the chlorine. Okay, the other guys are doing stuff. Here's this compound. Okay, here we see electrons on the right. Electrons on the right means it is losing electrons. Losing electrons is oxidation. The anode of an electrochemical cell, anode is always where oxidation takes place. And here's the zinc in this reaction. Here zinc is 0 as an element, and now it's +2. So it's going from 0 to +2. Its number is going up, and so that is oxidation. Reduction is if it goes down, and neither if it doesn't change at all. And those are the first 5 questions. Now, which of the following represents the reduction of fluorine? Reduction, we're looking for the charge getting reduced. So in this first case, it's going from -1 to 0, -1, and that's up to 0, so that's not the answer. Next one is -1 to 0 again. That's the same deal. Okay, third one is 0 to -1, 0 going down to -1, so that's our answer. And the last one is 0 to -1. Okay, so that could be our answer. Uh-oh. Okay, so what's going on? We're saying either one of these two. Okay, so these are both correct in that they have 0 to -1. That's a good clue. But where did the electrons go? On this side, the electrons are on the left. Here, the electrons are on the right, and one of those is incorrect. And we can see that the D, that's incorrect because we have 4 negatives on one side and 0 on the other side. That's just unbalanced. So this is the right change with the correct balance. So that's the right answer. So be careful of that one. 7. Which of the following reactions is not a redox reaction? Okay, we're looking for not a redox. Okay, one big clue. If you see a neutral element, then it is absolutely positive redox because it's 0 on one side, it's not going to be 0 on the other. Okay, so if you see neutral elements, you can knock that off. So that is not an answer because of O2. H2 and Br2, that's not the answer. Okay, here we have zinc, and hydrogen. That's not the answer. So the answer here must be D. Okay, and if we go back and look really carefully in all those compounds, everybody is the same as they were before. But really, you can knock off. If you see elements, then that means you've got a redox reaction. Elements mean redox. Okay, number 8. In which of the following reactions is chlorine reduced? Okay, so we need chlorine to go downward. Okay, probably from 0 to chlorine -1 because that's what it forms. So here's chlorine in a compound. That's -1 going to 0. That's up. Okay, here's chlorine. It's in a compound -1. It's in a compound -1, so that's neither. Here's chlorine neutral becoming chlorine -1 in its compound. That's our answer. And here again, chlorine in a compound is -1 both sides, so that's neither. So it's answer C. Number 9, the following reaction is the rusting of iron. Which of the following represents the reduction half reaction? Where reduction, means that they're gaining electrons. Gaining electrons is reduction. So we're looking for electrons on the left side. Okay, so we can knock this off. That's not true. Okay, it could be one of those two. Okay, and there is no reduction because this reaction is not redox. You got an element, it is definitely redox, so that's not the answer. So, of these two, we can look at them a second. We can knock off letter B because we have iron neutral picking up 3 negatives and becoming positive. That just doesn't make sense. That is not a balanced equation. It's negative on one side, positive on the other side. That can't be right. So it has to be the oxygen. Okay, the oxygen here is a neutral becoming -2. Its charge is going down. It's getting reduced. That's the answer, totally. Number 10, what is the correct overall reaction for galvanic cell that contains nickel and magnesium? Okay, nickel and magnesium. Well, let's look kind of closely at these. We can knock off 2 of these answers, okay, because somebody's charge is going to go up and somebody's charge is going to go down. And here on letter C, it's plus and plus becoming neutral and neutral. That cannot be the answer. It's not balanced because we have 2 positives becoming 2 neutrals. Everybody's reduced. And that can't be the right answer. On the bottom here, that cannot be the answer because you have magnesium. Magnesium turns into nickel and nickel. That just doesn't even make sense. Okay, so that cannot be it. So it's either going to be nickel turns into nickel ion while magnesium becomes neutral, or nickel becomes neutral while magnesium becomes positive. So it's going to definitely be one of these two. And what we have to do to answer this is go back and look at the E0 values for these two reactions, okay? And whichever one is higher is the one that is going to change because, they're going to see it as nickel plus 2 electrons becomes nickel neutral, and magnesium plus 2 electrons becomes magnesium neutral. And one of those is going to happen as is, and the other is going to go backwards. So we're going to go back and find that chart and look up nickel and magnesium. Here is magnesium. And nickel, nickel, nickel is here. Here's nickel. Okay, so nickel is minus 0.25, and the other one's minus 2.37 for magnesium. That's volts. So definitely, minus 0.25 is much larger, much less negative than negative 2.37. So that means nickel is going to go forward, and this magnesium one is going to have to be written backwards. So we're looking for a reaction where we have nickel ion and magnesium metal. Nickel ion, magnesium metal. That's answer B. So that's actually a pretty easy question, but you do have to go back and look at that chart. That's the key. Okay, calculate number 11. Calculate the E0 for the following reaction. Okay, so what we have here is the E0 of the cell, the voltage of the cell, is equal to the reduction potential plus the oxidation potential. Okay, so as an example up here, if we were looking at these two numbers, okay, this number here, the negative 0.25, that would have been our reduction potential, and this one is going to go in reverse, so we're going to change its name to the oxidation potential and change its charge. Going to change the sign on that. So we would have added together this guy and this guy to get our answer. So we're going to do the same thing down here. And we're going to say, who is gaining electrons? Who is gaining electrons is the cadmium and the cadmium. So that is going to be the reduction. So the cadmium number is going to go there. And then the aluminum number, okay, is going to be this guy, except we're going to have to change its sign. So we've got to go look up cadmium, normal, aluminum in reverse. Cadmium, normal. Cadmium, cadmium, cadmium. Here it is. Here's cadmium, normal. And aluminum we're going to do in reverse. We need negative 0.4 and positive 1.66. Negative 0.4, that is the voltage. And we're going to change the sign positive 1.66 because in the chart it was negative 1.66, but since it's the lower number, it gets turned around. So, excuse me, negative 0.4, positive 1.66, I can just do it in my calculator. I'm going to get 1.26, and that's going to be a positive value, positive 1.26. There it is right there. Okay, but again, you have to use that chart. Okay, number 12, given the following reactions, okay, what is the E reduction for platinum? Okay, so we're going to do the same thing we just did above here. Okay, the E of the cell equals the voltage of the reduction plus the voltage for the oxidation. Okay, now they are telling us a couple of things. They're telling us the cell is positive 0.38 volts. Okay, that's that number. Now, of these two, okay, the platinum, okay, platinum is going from 2 plus to 0, so it is getting reduced. It's going from 2 to, so this number here is going to be the reduction, okay, that's what equals, okay, and the silver number is going to go here. This is for silver, but because it's the lower of those two, because it must be because it's getting oxidized, it's going from 0 to plus, then we're going to use its number in reverse. So we're going to go back and look at silver, silver, silver. Here's silver. Okay, positive 0.8. So in here it's going to be negative 0.8 volts. Okay, we change the sign because it's oxidation, so this platinum must be larger than positive 0.8. So here's our math. 0.38 is equal to x plus negative 0.8. So I'm going to add positive 0.8 to both sides. So x is going to equal 1.18. I hope I did that right. Okay, so positive 1.18 volts, and there it is right there. And that's the answer. So platinum, if it was in the chart, it's not. If it was in the chart, because if it was in the chart, we just look it up. It must be high number because it gets reduced and makes silver go backwards. So it's higher than 0.8, so 1.18 is very reasonable. Okay, 13. This is referring to that potato lab. And we say, what's the correct order of reduction potential? Okay, we don't even really want to look at the anodes, we want to look at the cathodes. Who was the cathode the most? They're going to be highest in the chart. They have the highest reduction potential. So gold, gold, and gold 3 times. So that means that's not the answer, that's not the answer. Okay, then second best was silver, silver. Okay, and that's both the same. Third best was copper, and the worst was zinc. Okay, so we went gold, silver, copper, zinc. Okay, as answer D, and that was a pretty easy question. Okay, so 14, 15, and 16 are all about this galvanic cell made with silver and copper. Okay, so now we actually need some information from our chart before we do this. So silver, okay, so we're going to find that on the chart. It's going to say silver. I just did that wrong. I put 2 plus, and it's 1 plus. I should know that. Okay, silver plus an electron becomes silver metal. And we just saw that on the chart a minute ago. It's positive 0.80 volts. I still remember that. Okay, the copper on the chart is going to be copper 2 plus 2 electrons becomes copper metal. And I have to go back and look at that one. I think it's copper. Here's copper. Positive 0.337 volts. Positive 0.337 volts. Now, just looking up those two tells us a couple things. This is going to happen as is. This one's going to happen in reverse. This one is reduction. This one is going to end up being oxidation. Okay? And that means that this guy, the silver, is going to be our cathode, red cat, and the oxidation is going to be our anode. So all that stuff goes together. Okay, so which electrode is the anode? Okay, we've answered that already. It's the copper metal. The copper metal. Okay, so this guy here, that's our anode, that's our cathode. Okay, what is the overall reaction for this cell? Okay, so silver is going to go as is, copper is going to go reverse. So we're going to put those two together. So I have Ag plus an electron becomes Ag neutral. And I'm going to rewrite the other one in reverse. It's going to be copper metal. Turns into copper 2 plus 2 electrons. So in order to make this work, I'm going to double everything in this first reaction, put it together. When I put it together, the electrons cancel out. So I have 2 Ag pluses plus copper turns into copper 2 plus 2 Ag neutrals. And I'm looking for an answer that looks something like that. So ion, silver ion, and copper. Okay, and this answer 1. Right there, that's my reaction. So again, I use up from information from the chart. Okay, the next question is, okay, what is the voltage for this cell? So I'm going to do it back here while I can still see my numbers. Okay, so the E of the cell is equal to the reduction potential plus the oxidation potential. So the reduction potential for this is my positive 0.8 volts. And my oxidation is this guy with the sign change, so it's negative 0.337 volts. So my answer that I want is 0.8 minus 0.337, and that's going to be something like 0.47, 0.46. Okay, and there it is, 0.463, but it's positive because it's a larger positive minus a smaller negative. Okay, 17 and 18, an electrochemical cell using a potato is created, like our lab, using copper and aluminum. Okay, which of the following takes place? Okay, so copper and aluminum. So again, we need to go back and look at our numbers. So on the chart, we're going to see copper plus 2 electrons becomes copper metal. And we just saw that the E0 value is positive 0.337 volts. Now aluminum is 3 plus 3 electrons becomes aluminum metal. And that one, we're going to go look at the chart again. Aluminum, here it is. That was the one that was negative 1.66 volts. So negative 1.66 volts. So that tells us already this guy is going to be the cathode. That's reduction. This one's going to be the anode. It's going to work in reverse. Okay, if we had to use the numbers, we're going to change the sign. But let's answer the question. Which of the following is the reaction takes place at the anode? Okay, well, this is the higher one. That's cathode. This is the anode. I need the aluminum, and I need it to go in reverse. So aluminum metal turns into aluminum ions. Aluminum metal turns into aluminum ions. Okay, and that's answer A. Okay, so that I can tell that just from the numbers. The smaller number, this reaction in reverse. In which direction do electrons flow through the potato? Okay, for electrons always flow from the anode to the cathode. And I would just memorize that. Always from the anode to the cathode. And it makes sense because anode is oxidation, that's losing electrons. Okay, cathode, you're gaining electrons. So, to lose electrons and gain, that means it always has to go from the anode to the cathode as far as electrons are concerned. Okay, so who's the anode? We said that the anode is the aluminum and the copper is the cathode. So they're going to go from the aluminum to the copper. So from the aluminum to the copper electrode. And that should be the right answer. Into both, they can't out of both. They cannot go into both and out of both. That doesn't make sense. Okay, so anode to the cathode, aluminum to copper. Okay, consider the following reduction potentials. Which substance is most difficult to reduce? Okay, so if we have these in order, and just double check that these are from high to low, that's good. Okay, then this guy would be the most easily reduced. So this guy is going to be the most difficult to reduce. So the barium ion, that's going to be the answer that's most difficult to reduce. Now, which of the following reactions takes place at an anode when an electric current is passed through a solution of Ki? Okay, well, this is the whole thing. This is talking about that reaction we did with the 2 pencils. Okay, and what we have to think about is anode. That's a big clue, so that means we're talking about oxidation. Anode is oxidation. And who's going to be oxidized? Okay, we have the negative side, we got the positive side. At the negative side, that has too many electrons because the electrons have been pumped onto it from a battery. So whoever touches it is going to gain. Gain is reduction. So we don't want the negative side. Okay, we want the positive side. Okay, now who's going to be attracted to the positive side? Okay, the negative iodine is going to be there. So one possibility is going to be that the I minus is going to pick up electrons. Okay, but we also always have the option that maybe the oxygen is going to get oxidized. So either the iodide could lose electrons, or here's this water that could lose electrons. So these are both possibilities. Now we have to go back and look at their oxidation potentials. Okay, now these are all written here as reduction potentials. So if we find the water turning into oxygen, okay, that is on here, but it's going to be on here in reverse. Here it is. So it's this guy, but that's reversed. So the number we want, not positive 1.3, oops, we're going to want negative 1.23. And that's the oxidation potential. And iodine will be on, here it is again, and this is positive 0.535. So we're going to use it as negative 0.535. And of these two, okay, this one has the higher oxidation potential, so it's going to be C, not B. So these other ones, we can knock those out altogether. Those are not the right kind of thing. They're not oxidations, okay, and anode. But of those two, water and iodine, the iodine is the one. And if we remember, that's the one we did. We did this in class, and it's where it turned yellow because of the iodine forming, and that's the one we want. Okay. Okay, now we're on to the FRQs. So again, here we have this chart. We're going to need to refer to that. Okay, and we're talking about aluminum and silver. Okay, and that's the key, aluminum and silver. So let's find those two numbers. There's silver. We're going to be needing that. And aluminum is over here. Okay, now just seeing those two things, this silver, that's the higher number. So that is going to be the reduction. That's going to happen at the cathode. And that reaction is going to occur as written in that direction. Okay, this guy over here, it's lower, so it's going to have to be used in reverse. So we're going to be using the reaction written backwards. This is going to be oxidation, and so therefore this is going to happen at the anode. And the voltage that we're going to use, we're going to call that the oxidation potential, and we're going to use positive 1.66 volts. So all that stuff we know just from where those two things are on the periodic table. I mean on the reduction potential chart. So let's start answering questions. Okay, write the equations for the reaction that takes place at the anode and the cathode, the overall reaction and their potentials. Okay, so the cathode we said is the silver. So that's Ag plus an electron becomes Ag neutral. We're going to use the reaction as is, and its voltage is positive 0.80 volts. Okay, the anode, we're going to write that in reverse. So instead of Al3 plus, we're going to say Al neutral turns into Al3 plus and 3 electrons. And its voltage then is going to be positive 1.66 volts because we turned it around. So this guy officially we would call that the reduction potential. That's an E. And this guy here would be called the oxidation potential. Okay, what's the overall reaction? We can see what's happened here is that this top one is going to get multiplied by 3. So when we're all done, I'll change colors. It's going to be 3 Ag pluses plus an aluminum. Turns into aluminum 3 plus 3 Ag neutrals. So 3 silver ions plus an aluminum neutral turns into aluminum ion and 3 silver neutrals. Now what's going to be the voltage? We don't care the fact we multiply by 3. We're just going to use these two numbers as is. And positive 0.8 and positive 1.66. I get, excuse me, 2.43 volts. Okay, and we would call that the E of the cell. So we just got several points by filling all that in. And this information right here on this chart. So again, that chart's really important. So now draw this, label this, okay, anode and cathode. Okay, I'm going to put the anode on the left, just because I like to do that. And I can put cathode on the right. Okay, so if my anode, I said my anode is my aluminum, so this is aluminum metal in a solution that has aluminum ions. And my cathode then is going to be a silver metal in a solution that has silver ions. Okay, that's kind of sloppy. I'll try that again. Ag+. Okay, so that's, I got that one, I got that, I got that, I got that. Okay, I've already labeled the anode and the cathode. Okay, I know that the flow of electrons always go from the anode to the cathode, so I would show it this way. And, just keep doing it twice. And the salt bridge, okay, this guy here is the salt bridge, and that is not a wire, that should be some kind of a tube or something where ions can flow. And I'm just going to put an arrow and just show that's my salt bridge. And that's the entire practice test. So again, use this chart. Is very, very, very useful. The higher of the two is the cathode, the lower of the two is the anode. The lower of the one gets reversed, change the sign, and then just do what it asks you to do. Good luck on your test. I just see one tiny problem here, and that is that this should be 2.46, not 2.43, but other than that, we're doing pretty good.